This series of videos will be about section 7.1, Systems of Equations in Three Variables from College Algebra in Context. We'll be solving systems of linear equations in three variables using the elimination method. We'll find solutions to dependent systems and determine when a system of equations is inconsistent. So these are the things we can do with the systems of equations. We can interchange any two equations. We can multiply both sides of the equation by the same non-zero number, and we can multiply any equation by a number, add the result to a second equation, and then use that equation in place of the second one. Here's a system of equations. We can try that on. Okay, first thing I'm going to do is take the top equation, and I noticed this has a negative x, a negative 3z, or negative z, negative 3z, and negative 3z. So I think if I take this top equation times negative 3, that will result in negative 3x plus, or minus, it's a negative 3, negative 3y, now plus 3z will equal 0. Let's add that to the second equation. X plus 2y minus 3z equals negative 2. When I add those, I'll get negative 2x minus 1y, the z's will be gone, equals negative 2. Well, since I've got that negative 3 down here, let's also take this multiplied, the top equation times negative 3, and add it to the bottom equation. 3x minus y minus 3z equals negative 2. Oh, x's go out also, so I have negative 4y equals whoops, this is negative 1, not negative 2, equals negative 1. So y turns out to be 1/4, and I already have one solution. Let's take that value and fill it in this equation. So negative 2 times x minus my y at 1/4 equals negative 2. So negative 2x, adding 1/4 to both sides, my negative 2 would be negative 8/4 plus a 1/4 will be negative 7/4, and divide that by 2, it will be 7/8. So x equals 7/8. Let's take both of those values and fill it in the top equation. So 7/8 plus 1/4 minus z equals 0. Well, adding these two together, 1/4 is the same as 2/8, so I'll have 9/8 equals, add the z to both sides, equals z. And I now have all three solutions. And you can check those in all three equations, or in these two equations, and fill them in also, and it does check. Now you do need to be careful not to end up with two equations that still have three variables. You eliminated y from one pair and z from the other pair. It doesn't help. So here's one of these to try. And the first thing I'm going to do is add the top two equations together. That will give me a 5x plus 5y equals 5. I was able to eliminate these z's because these were additive inverses. Now I'm going to take the second equation and multiply it, or the third equation, and multiply it by 2. That would give me 2x minus 2y plus 2z equals negative 18. And I'm going to add that with the top equation. So bring that down, 3x plus 4y minus 2z equals 14. Adding these, I'll get 5x plus 2y equals negative 4. I'm going to put that lined up over here. 5x plus 2y equals negative 4. And I'm just going to change the signs of all of this bottom equation. So make it a negative, and a positive. And then I can add them. I'll get 0 x's. I have 3 y's equals 9. So I found out that y equaled 3. From there, I can go to one of these other smaller equations. Say I go to this one, and I found out that 5x plus 6 equals negative 4, 5x equals negative 10, and x equals negative 2. Now I'm going to take both of those into this equation, both my x and my y that I already know, and have negative 2 minus 3 plus z equals negative 9. So I'll have z equals negative 4. And my ordered triple becomes negative 2, 3, and negative 4. I always must put them in that x, y, z order.